All right, boys and girls, welcome back to a rowdy version of the drive-thru, sponsored by the deli. Hope everyone's looking forward to a snowy weekend without blizzard bags. You remember blizzard bags? Okay. All right. So today we get into triple integrals, okay? And we luckily have a pretty good foundation on these multiple integrations, so I don't have to kind of start from scratch. So we're going to go right into an example. I want you to try to set up to find the volume, a triple integral, for a hemisphere with radius 1. So just like before, I draw two pictures. So here's the 3D version. Okay, that's what we're trying to find. And then you give yourself an aerial version. Okay, so we've got to decide our order of integration. I tend to have it dz something, mostly because I'm used to drawing these shapes this way, and then that makes it z dependent. Does that make sense? So in this case, remember that a hemisphere it starts with x squared plus y squared plus z squared equals 1. That's a sphere. So the hemisphere is the positive version of that. And you might be already wondering about polars. We're going to go strictly in rectangulars today, okay? In fact, there's no such thing as triple integrals and polars, because polars is a two-dimensional system. Now you're probably wondering, well, what is it? Well, you're wondering that because we skipped that one section, which was spherical and cylindrical. Okay, spherical is crazy. It's like the angle. Take something and angle it against the XY plane, then angle it against the YZ plane, and take an R. It's really hard to visualize, so that's why we skipped it. Cylindrical is actually really easy to visualize. You're standing on the floor. The floor is polars. So it's r comma theta. And then the axis that goes up is still just z. So cylindrical is like a morph of the two systems. It's like half polar, half rectangular. Okay? The floor is a circle, and our height is just a number. So that one's easier to visualize, okay? All right, so anyway, rectangular. So z goes from what to what? Okay? Now, I'll help you out with this. Remember that these bounds have to be constants. Okay? So we've already determined dz here. And I'm going to make dx our outside bound. So what's x going to in this? From -1 to 1. Okay? So that means we've got to write our y as a function of x. So what is this equation here on the top of our region? That's right. It's the positive version of x squared plus y squared equals 1. Okay? And then down here, okay? So that's what our bounds are here. Oh, geez. Oh, my gosh. There we go. And I just said set it up, so we're done. Now what I hope you're thinking is, what's the point? We just did this, and we would use what? How many integrals to do it? 2 with that as the function. So I get you. There is no point. The point of that was to get some practice. Okay? Got it?